Hi there, hello, Sindri here. The premise of this video is pretty straightforward. I'm going to do an IQ test, and to the best of my ability I will try to explain what the correct answer is and try to explain why the right answer is what I think it is. So I have two reasons for doing this, and neither of them involve me bragging about my IQ, whatever that happens to be. But my two reasons are basically as follow. In one of my courses, I have a 4-hour lecture with almost 180 slides where I talk about the concept of experts. What is an expert? What's the definition of an expert? What is it that makes an expert? And how can we become experts? And how do we identify the experts? And how accurate are experts in their predictions and forecasts? So that was the topic of my 4-hour lecture. And while I was doing that lecture, one variable that kept popping up all the time was IQ. And I didn't really do that good of a job explaining what it is. So for the purpose of my course at least, I think that the best way to explain IQ is basically just to show an IQ test. IQ is whatever it is that the IQ test is measuring. I think that's the best explanation of it. So I'm just going to show that for that purpose. But my second reason for talking about or showing an IQ test is many companies, unfortunately, they have IQ tests as part of the hiring process. When you're applying for a job, they will just, given that you have sufficiently good grades, they will just give you an IQ test in return. And that's kind of frustrating. You have A's in every single course and then you're really bad at the IQ test. So in theory, you cannot increase your IQ. There's a lot of empirical research on these IQ training apps that you can have on your iPhone or smartphone, and empirical research shows that they don't actually do anything. They don't work really, and there's a good reason for that, and that reason is purely from the definition of IQ. IQ is a measure of fluid intelligence, and fluid intelligence is intelligence that is orthogonal to experience and knowledge. So no matter how much you learn and how experienced you are, then you cannot improve your IQ, just purely from definition. The thing is though, no IQ test is a perfect implementation of the theoretical construct, the theoretical definition. So to the extent that an IQ test is not a perfect implementation of the theoretical concept of IQ, to that extent, we actually can improve our IQ. Just to give you an example, imagine that in the IQ test you're given the following number sequence: 1, 1, 2, 3, 5, 8, 13. What is the next number? Now imagine that there are two people taking these tests, A and B, and A's IQ is actually greater than B's IQ. However, A hasn't heard about the Fibonacci number sequence, but B has. So what's going to happen here is that B will immediately realize that this is just the Fibonacci numbers. So the next number is going to be 21. So very fast, B is going to solve this. A, however, who hasn't heard about Fibonacci, is going to probably spend a little bit more time to figure this out and then realize that any number is equal to the sum of the two preceding numbers. So 1 plus 1 is 2, 1 plus 2 is 3, and 8 plus 13 is 21. The final number is 21. So here, obviously, having knowledge and experience does help you. So this would be a particularly bad question to have on an IQ test. Yet it happens all the time. When I was a kid, I used to read a lot of these illustrated science magazines, and at the back of them there were always this small IQ test that you can do. Not very good at it initially, but as I was doing more and more of them, I started to recognize exercises that had very similar patterns. Obviously, there was an imperfect implementation of the IQ concept, so therefore experience did help. Okay, so just two final warnings and caveats before we jump into the actual test. First of all, this test is not going to be a valid IQ test of me because I've done the test before. Second of all, I don't actually know all the answers. I could be wrong about some of them, but based on the final score, we'll get an indication of how well I did. So specifically, as most of these tests, they are capped at 145. So if we get 145 in the end, that means that we did everything correct. So without further ado, let's just jump into it. Okay, let's get started. Here's the test. You have 40 minutes to do 36 questions. and they're all basically in the same format. There's always a 3x3 matrix, and each cell of this matrix has a particular figure, and the bottom right corner is always missing, and you have 8 different alternatives to choose from. So let me try to explain how to solve this to the best of my ability. I don't know the answer to everything, but let's try. So this one is so simple that it's really difficult to actually explain the logic here, but yeah, you know, circle, or red ball, red ball, red ball, and I guess the last one also is a red ball. This one here, I can use like a topological solution here. So you can move from one cell to the neighbor cell, and there's usually some kind of rule. So for instance, if we start in top left here and move one to the right, we see that it is expanding. First there's 1 leaf, then there is 2 leaves, and then there's 3 leaves, and it's expanding clockwise. So 1, 2, 3 going clockwise. Also, you can move from the top left corner, moving 1 row down. If you do that, you'll see it's the same shape, it's just that the color has changed. So you can either move to the right here, or you can move down. So 2 different rules by moving to the right and moving downwards. So if, for instance, here, if we move to the right, then we should get an additional leaf here. So there will be 3, 1, 2, 3, and the color would be blue. So that would be this one right here, F. Again, here we have some kind of topological rule. One different rule when you move throughout the columns, another rule when you move through the rows. So if you start in top left there, go 1 to the right and 1 to the right, you'll see that this one line is just switching position. It's all the way to the left, then the middle, and then to the right. And if you go downwards, we go from 1 line to 2 to 3. So 1, 2, 3. Position to the left, position to the right. There's 1, here's 2. So over here we would have 3 lines, and will be positioned all the way to the right. So that would be this one, here, this one, 1, 2, 3, position to the right. This one right here, I guess this one is kind of fundamentally different from the rest. So this one is not a 3x3 matrix. But again, so here we have, instead of looking at the myopic rule, I guess you can just like zoom out and see the whole picture, and it's kind of painting a square, I suppose. So again, it's kind of so simple, it's really difficult to actually explain what the correct answer is, but beyond just saying, it's alternative C, obviously. What about this one? Again, some kind of topological rule here. Moving, starting top left corner, going to from first column to second column, we have 1 different type of rules. Going from first row to second row, we have another type of rule. So the rule moving to the right there is that we stack another square on top of the one we already have. So here's 1, we stack another one on top to get here, stack another one on top to get here. And if you're moving downwards, we're just taking the blocks we have and move them to the right. So here it is positioned to the left, then to the middle, and then to the right. So kind of the inverse of what we saw in one of the previous exercises. So 1, 2, 3, 1, 2, 3, 1, 2, 3, position to the right. So that will be alternative B. Here, once again, we have some kind of topological rule. And that is namely that if we move to the right there throughout the columns, this vertical line is changing position. So it starts here at the right, then it's middle, and then it's to the left. And if we move downwards here, we will see that the vertical line remains in the same position, but the horizontal line is changing position. So from being from the top to the middle to the bottom. So for the bottom right corner here, we will have something with a horizontal line that is on the bottom, and we would have a vertical line that is all the way to the left. So that would be, let's see, where is it? That would be H. Here we have, well, I guess you could say, so this one is actually interesting. First time I looked at it, I devised a different rule, and when I came back to it, I saw, okay, there's actually even easier rule. So different rules or different perspective can actually generate the same answer. So initially I was thinking that as you move to the right here, these two boxes are just moving in opposite directions. So the top one here is moving to the right. So first is to the left, middle, and then to the right. The bottom here is to the right, then middle, and then to the left. Same here, these are two boxes, and they like move to the middle, and then they move opposite direction. So that would be one way to look at it. So that would mean that this one is to the top right, then it's middle, then will be left, and the opposite down here. So the answer would be F. But then I kind of start thinking, okay, let's not use the topological heuristics here, and kind of zoom out and see the whole picture. And you can kind of see that all of these are kind of pointing towards the middle here. So this one is pointing to the middle, pointing to the middle, pointing to the middle. So it's kind of just moving around, right? So F again. So number 8 here, this one actually, I would think, actually looking back at the whole question set, this seems to be the most common one. And it's basically that you have different shapes. And in this particular case, you have triangle, circle, and square. And it's kind of like a Sudoku rule here. So every row and every column needs to have all 3 shapes. So just look at this row here. You have a triangle, circle, and square. So each row and each column needs to have all 3 shapes, but you cannot have duplicates, because if you have duplicates, you wouldn't have space to have all 3, right? So if you look down the column here, for instance, it's the same thing. We have all 3 different shapes: triangle, circle, and square. So bottom right corner here, the missing one, what are we missing here? Well, we're missing a circle. Square, triangle, circle. Same if you look at the column: square, triangle, circle. So circle, circle, it is this one. This one is not a 3 times 3 either. So this one, again, kind of falls in the category of being so simple that it's really difficult to actually explain what the answer is without just saying, here's the answer. So this red thing to the right, to the right, to the left, I presume it would be H here. Here's another common rule. So this one is kind of like, okay, that's how to explain it. So if you combine the, for a particular row, if you combine the left column with the right column, you get what's in the middle. So look at this second row, for instance. A circle and a circle comes in the middle together here to form this like overlapping circles. So down here you have like a triangle with the pointy edge upward. In the middle here you have this triangle, and together with something missing here. So what we missed to create this sum is kind of the triangle pointing downwards. So that would be C. So here clearly this rule for like each row. I can't really deduce much of a rule if you go downwards, if you are in one particular column and go down through the rows. But yeah, so C would be the answer here. This one is, again, I think you need to think of it as the rule existing within the particular row. So for instance, here we have a triangle, a vertical line, and then we get this elongated triangle. Same on the second row here, we have a circle, horizontal line, and we get this elongated circle, or ellipsis, I suppose would be more correct to call it. But you see, like we start off, this is the input, and this is like a transformation we're going to apply to the input, and this is the output. So what I think this vertical line here is telling us is to elongate, vertically, and here elongate horizontally. And the third row here, the input will be the square. Transformation we're going to do is to elongate it, both vertically and horizontally. So if you do that, that's just like scaling up the whole thing. So that would be C here. So yeah, it's like being expanded both this way and this direction. So that would be alternative C. Here we are back to kind of like a Sudoku rule again, but this time it's a little bit more complicated. First time we saw it, we had like the circle, square, and triangle. Sorry. But this time, we not only have the shape, we also have like the positioning, how it's angled. So we need like a 1 line, 2 line, and 3 lines on each row and each column. So here we have 1, 2, 3, and here we also have 1, 2, 3. So here we are missing the 1, we have the 2 and 3, the 3 and 2, so we're missing 1 line here. But we have alternative A and C and H. So which one is it? Well, see that they are positioned differently. So we have all 3 of the 2's, for instance. So we have it being aligned vertically, we have it being aligned horizontally, and we have it being aligned 45 degrees. And it's the same thing with the 3 liners. Here it is horizontal, vertical, 45 degrees. So we need the 1 liner here, and we already have horizontal, we have 45 degrees, so we're missing the horizontal one, so H. So I'm gonna guess that this H is the correct answer. What about this one? This one we have again like another topological rule. And by topological I mean that you just start in one figure here, and if you just move one position you will see like a transformation, like a change, right? So what seems to be happening here is that as we move here to the right, and then over here, as we continue to move, it would seem that there's always 2 like flower petals, and they are moving one position clockwise. You see that? So the furthest one here, if you move clockwise, it would be like top position, and then it becomes 1 o'clock here, 3 o'clock. Well, we don't have like exactly 3 o'clock, yeah, approximately, yeah. So the opposition, 45 degrees. Yeah, you see, so it's moving one position clockwise. On the first one here is always blue, and the one that's behind it is changed in color, and here we get kind of the Sudoku rule again. We need yellow, red, and green on each row and each column. So down here, yeah, so we need to kind of combine 2 perspectives here, both the topological rule and also the kind of like a Sudoku rule. These are not official names, it's kind of how I like to classify them. So if it's here, then it will be, blue one will be in this position, and we're missing the red. So that will be alternative E for echo. I feel like I'm doing a really poor job of explaining what's going on here. Anyway, so here we have, so what I'm guessing the rule here is that we need to look at each particular row. It doesn't make much sense to compare different rows in a particular column like this. That doesn't make more sense to me. This makes more sense. So what's going on here is that if we add this figure with this figure, we get the figure over here, with the twist that overlapping lines get cancelled out. So if you place these 2 on top of each other, you see the middle segment here, this vertical line, they're going to be duplicated, going to be 2 of them on top of each other, and they will cancel each other out to form this thing. So if I take this plus sign and put it on top of this left pointing arrow in this box, then this horizontal line will be duplicated and will disappear, but we will add this vertical line, and that will leave us with whatever this is. So same over here, duplicate, going to be cancelled out. We still have this line, and we get this kind of sloped lines. So that would be G. You see, this one plus this one should be equal to G. Here we kind of have something similar from before. We look at each particular row, I would say, and the left column plus the right column is equal to the middle column. So here we have looks like an envelope, right side of an envelope plus the left side of an envelope. In the middle is this full thing. So here we have the arrow pointing to the bottom right. To get this, we're missing arrow pointing top left, so D. Here is just a simple thing again. Just look at each row. The first one plus the second one is the third one. So the triangle is put inside the circle. It gives us a circle with a triangle on the inside. Circle is put inside of the square, and that leaves us with a square with a circle inside of it. Down here we put a square inside the triangle, and that gives us a triangle with a square inside. This one is kind of a topological thing, so if you start with this one and move one to the right, we will see that this square is just moving clockwise. So first it's in the top right corner, then it's in the middle right, and then the bottom right, and then we leave the first row and go back to first column on the second row, so over here. So move from bottom right to bottom middle, and then from the bottom middle to the bottom left, and so on and so forth. So down here we have top left, middle top, and then will be top to the right. So that will be where is it? F. Here we have first look at this particular row. So the first figure, put it on top of the second. Overlapping lines get cancelled out, and that leaves us with the one over here. You see the circle and circle cancel each other out, and you're left with the diamond shape. So here, a square, put it on top of the square, square disappears, only thing you're left with is kind of the dot there, which would be E. Here we have yet again a kind of a topological rule. Can't stop talk apparently. But rather than moving to the right here, I think we need to stay within a particular column, and then just go downwards. So here we have these two squares next to each other. It's on the top here. And as we go down, it is literally just moving downwards. You see, it's just falling down like gravity. You hold it here and it falls down. Same there, on top, middle, bottom. And this one here, so this one you see is moving downwards, and so is this one. So this one actually a little bit uncertain, but I think what will happen here is either that it will both be on the bottom here, or that this one will loop back up again. So I feel like I'm missing something here. Maybe this is really obvious, but yeah, I suspect that it will just loop back up again. So I'm gonna go with one on the bottom here. So this one was the bottom, and this one loop back on top. That's what I'm gonna go for. So B. But then again, I feel like it also could be C. So I'm actually not quite sure about that. In either case, I can eliminate most of the other ones. So 50-50 sounds good to me. Is there an alternative interpretation here? Could be. There could be like a better perspective here that yields a more conclusive result. But let's go for B. Here, once again, we have the Sudoku rule. So not a topological rule, but the Sudoku rule. So there are three basic shapes here. Whatever this is, this and that. You see the three different shapes. And we need each of these shapes on every single row and every single column. But additionally, we have another aspect here, and that's the color. Red, blue, and green. And we need all of the colors on every single column and every single row. And also, if you look at a particular shape here that we have all three of, this one, for instance, here is pointing up. Here is pointing like downwards to the right, and downwards to the left. So it's both the shape, the color, and the alignment, the angle. So three things here needs to be present on every single row and column. So what we are missing here is not this shape. This one we have all three of. It's not this one either. So what we're missing is this particular shape, and it is missing in red. And the position that we're missing is for it to point upwards. I mean, kind of difficult to find what it means by upward, but C, yeah. So C has the right color, the right shape, and is pointing in the right direction. So Sudoku rule, and the three different aspects that you apply the Sudoku rule to: shape, color, and rotation. This one here is kind of a topological rule. So I'm starting on the top left here, and if you move to the right, you have a different rule compared to moving downwards. So if you're moving to the right there, you see this, so it's basically like a plus sign here, and on the tip here, on the edges, you have this like a curved figure. You see 4 of them, and as you move to the right there, they are being pushed further in towards the center. You see that? So this thing here is being pushed from the edge to the middle, all the way to the center. So that's moving to the right. If you move downwards, however, this, I'm not sure what to call it, like this curved line, it's like it's a certain shape and it becomes like stretched, so it becomes bigger. So it's covering more of the like circle around there. So see, as you move down, it stretches out. So if we combine that, so over here, what will happen if it's all the way drawing the whole thing and we move it inwards? I think what's gonna happen is that, well, it's definitely not E, not F, not B, not C, not G, not H, not D. Yeah, so A here actually for me seems the correct answer. So different rule moving to the right and different rule moving downwards. So over here, I think A would be the correct here. Here we have again the Sudoku rule. Now you see the Sudoku rule comes all the time basically. So every single column and row needs 3 different shapes. We have the hourglass, we have the beehive, and we have the whatever this is. It looks like a poor drawing. No, it doesn't matter. So this shape, and this shape in both column and row. And the one we're missing here is this particular shape. But there's an additional thing going on here, is that the shape can be plain without anything, or it could have the red circle around, or it can have the red square around. So plain, we have the one with circle, so you need this type of symbol with a square around it, and that would be E. Yeah, so answer E. And here, once again, we have the Sudoku rule. There are 3 basic shapes. One is like a square. Then we have the bathtub. And then we have this square where the bottom is like bulging inwards, right? And it can, if you look at the square, for instance, it can either be like completely closed, completely open, or like half open, half closed. So 2 different aspects going on there. What we're missing here is the bathtub symbol. We have the 3 squares. We have the 3 whatever this shape is. So what we're missing is not closed, not open, but halfway open, halfway closed. So E. Here we have Sudoku rule again. Every single row and column needs 3 different shapes: circle, triangle, and square. So what we're missing down here is the triangle, as you can see. And there's also this blue thing going on there. The blue thing can either be, for each row and column, it seems to be twice on the inside of the shape and 1 time outside. So inside, inside, outside, inside, inside, outside, inside, outside. So we're missing 1 here with inside. So triangle with the blue thing on the inside. And also for every row and column, the blue thing is once completely filled with blue, and other times it's kind of hollow. So here we need triangle, blue on the inside, also completely colored. So that will be C. Yeah, C. Here we have topological rule. Starting in the top left here, if I move to the right and to the right and then loop back over here, you'll see that this dot here is just moving clockwise. So first it's here, then it's here, then it's here, then it's here. So it's just moving 45 degrees clockwise every single time we move to a different shape. But the additional rule here seems to be that when this dot is like on the top here, so either pointing up right or up left, the big circle is white and the dot is black. But when it's downwards, like pointing down left or pointing down right, they invert the colors. So the small thing becomes from black to white, and the big one becomes from all the way around. So here pointing down left, up, so up right. I'm gonna point up right. That would be this one, except that's the wrong color scheme. So it will be F. Would it not? Yes, yes, yeah. So it will be like this one. Here we have topological rule, and what you need to realize is that it's kind of like 3 clock arms, and sometimes these arms are overlapping each other. So look at this one, there's 3 of them. So this the longest one here in the middle, so it's centered here. It will rotate clockwise, as you can see. Now it's like slapping here, and then becomes vertical, and then it's going to be 45 degrees, then horizontal, 45 degrees again. And this one here is going to move clockwise also. So first it's horizontal, then it's sloped, and then it's vertical. But then it's going to loop all the way up here. You see, now it's pointing downwards, now it's pointing upwards, and then now it changed again, 45 degrees, 45 degrees, 45 degrees, 45 degrees, and then it's going to loop, 180 degrees. So these 2 are going clockwise, and this one seems to be going counterclockwise. So if we are over here, this line is going to go up there. The long one is going to be horizontal, and this one is going to go loop all the way down. So that will be D. So 3 different arms, 2 of them going clockwise, all one going counterclockwise, and you cannot go outside the 9 red dots, so it's going to loop around. Here, what do we have here? This is not Sudoku. This is a topological rule, or Oracle transformation again. So if you look at one particular row here, you will see that this figure plus this figure will be equal to this figure, with the rule of overlapping lines cancelling each other out. So you have this line in both of them, and also this line in both of them. Combine them, and you're just left with the top horizontal and the bottom horizontal, which is this. So this plus this, what's that? I'm gonna cancel this line. I'm gonna have this. So this can be a little bit, this type of exercise can be difficult if you just thinking. It's a lot easier if you have like a pen and paper, and then you can very easily solve this type of, once you know the rule and the pen and paper. Like this one isn't that difficult, it's going to be alternative D here, I think. But like this one can get quite complicated because you need a lot of working memory in order to actually do it. Here we have, I'm running out of time. Here we have another Sudoku. So every row and column needs to have 3 different shapes. We have this kind of square, this green plus sign, and this, I'm not sure what to call this thing. Let's see, the 4 clover thing. And it's an additional rule here. It can be this kind of X on top. You can have the circle around, or the 4 diamonds. So what we're missing is this kind of blue shape here, and it needs to have this circle around. So that will be this one. Here we have an input. Here we have transformation, or a rule to apply to it, and then we get like the output to the right there. So yeah, the square plus this thing is going to be curved as specified by the S here. So this one is just telling it to kind of tilt. So this one here is a smaller square, and kind of the opposite of this one. So, well, it's not A and E, it's not C or G, it's not D. It is not H, because it's curving the wrong way. And it is not going to be F, because it's not rotated correctly. So I'm gonna guess B here. B seems to be, yeah, I'm gonna go for B. Could be wrong about that. Yeah, B or F, I'm gonna go with B. Here, if you look at the particular row, take the middle one here, put it inside the first one, then you get the one on the right. So see this window gets put inside here, we end up with this. This circle with a square, put it inside the circle here, well, we get the big square, circle with a smaller square. So put this one on the inside. So this time around, overlapping lines do not cancel each other out. So we would end up with E. Here we have a kind of topological rule, so we can start with this one and either move to the right or move to the bottom. So for me, I can't really explain the middle one here, but if you look at this, if you move to the right there, it's like someone's taking the box and then put their fingers to squish it in, like push the walls inside there. You see, it becomes like squeezed in. And then move from here to here. To me, it seems like someone is taking like these walls that were squeezed in, take them and kind of rotate them out. Then up with this. So that's basically the same what's happening on the row and the column here. So here, moving over there, it's like someone again squeezed it in. You see that? This segment is being squeezed in, so it's bulging inward. And then it's like someone, I think someone's gonna like taking it, like rotate it out again, right? So what I suspect is that it's going to be D. And also we can pretty much eliminate almost everything here, like A, B, F, C, G, H. And yeah, like E is an alternative for me, but I'm gonna go with D. So yeah, I feel like, yeah, it's either D or E, but I'm leaning toward D here. Here again, we have some kind of topological thing going on. So we have this X here, and we, like it's basically like 4 line segments connected together, not 2, but think of them as 4. And you grab one of them and rotate it for every time you move to a different figure, either to the right or to the bottom here, you see? So we take this one and rotate it to get this figure. We take this line, rotate it to get this one. We take this line segment, it's not one big here, it's 2 1. So take this one, rotate it to get this one. So you see, you're just taking one line segment, there are 4 of them, take one of them at a time and rotate them. So here, we take this one, rotate it, and we get A here. So that was actually surprisingly simple. Here we have, again, the Sudoku rule. We have noodle in both mirrored and not mirrored. And we have the 8. So we need all 3 of them on each row and column. And there's also different alignments of them. So what we're missing here is the 8 or the double noodle, depending on what you want to call it. So let's see, pointing upwards, so vertical, horizontal, and then 45 degrees maybe. So it's only alternatives here will be B and G. And let's see, what am I missing here? What am I missing? Is it going to be... Okay, no, this one I'm uncertain, but I'm gonna go with the B. But B or G, obviously. But let's see. Yeah, like this mirrored noodle is kind of throwing me off here. Let's see. Okay, I'm just gonna go with B. Here we have, yeah, not really a topological rule, but like if you add up the first, on a particular row, add up the first and the second, that's gonna give you the third one. So 1 on the inside plus another 1 on the inside is going to be 2 on the inside. You see that? 1 on the inside, 3 on the outside is going to result in 2 on the outside. So 1 black dot on the inside and 1 on the outside, they're going to cancel each other out. So what you're left with is just 2 on the outside. So here you have 2 on the inside, 2 on the outside. 2 and 2 cancel each other out, so you're going to be left with nothing. You can also go downwards here. 1 on the inside plus 1 on the inside is 2 on the inside. 1 on the inside, 3 on the outside equals 2 on the outside. 2 on the inside, 2 on the outside, just nothing. They both cancel each other out. And this one, I don't know. I couldn't figure this one out. So here's your moment to shine, moment to prove that you are vastly superior to me, intellectually speaking. Not intellectual, but like in IQ terms. I don't know. I no clue. I couldn't figure this one out. Maybe this is super simple. Maybe there's something I'm not seeing here. But I don't know. So should we throw dice? Should I throw dice here to determine which one to select? Okay, so A. This one I did figure out. We're almost at the end there now. So this one is basically just another Sudoku rule. But this one actually need a pen and paper in order to it isn't difficult. It's just that many things to keep track of here. So look at the particular row here. For each of the color ones, it's 3 different rules they can take. So you can have let's see, either 1, 2, and 3. So You can have the short segment, middle segment, and long segment, and need all three within each particular figure. And the three patterns, for instance, the blue one has 1, 1, and 3. Green one has 1, 2, and 3. And the red one has 2, 2, and 3. So each of the colors needs to exhibit all three of the patterns across the different columns and rows. So if we just map that out, it's going to be A. So A would be the A would be the answer here. This for process elimination. This one I don't know either, so I'm just gonna throw dice here, and it says F. This one I don't know either, so okay, 39, don't know either, so F. No, okay, so let's see. So 1 I don't know here for sure. 2, 3, 4. So 4 exercises, I have no clue whatsoever. If you are smarter than me, then you please comment and explain to me what the answer is. I would like to know. This is the limitations of my my intellect. So let's look at what we get here. It says 143. Obviously that is not valid because I've done the test before, as I stated. So you're supposed to only have like 40 minutes, but I have, I spent more time in that. I was sitting there, okay, thinking, okay, what is going on there? So I had more time in it, and I've done it multiple times, so 2 times now. So it not a valid result, but what it shows here is that we got most of them correct. And this test, if you do a little bit of hacking here, you will know for sure that like it cannot give you more than 145. So if you get everything correct, it will cap you at 145. So we are, I think we got almost all of them correct. So a few of them are wrong. 4 of them I don't know. So if you know the answer, comment and explain me how. Ketchup like in the fridge, or do you keep it in room temperature?